Ladies and gentlemen, it's 3 o'clock, and so I will start. Please just let me know in case you don't hear me very well or in case something goes wrong. Otherwise, I ask you to mute your microphones, some housekeeping here, so that we don't have any unwanted noise in this recording. Okay, ladies and gentlemen, a warm welcome to my talk, Striving for a Speedboat Pace. I'm Nicola Pascha, and I'm heading the new Kistler Innovation Lab. So first of all, I would like to thank the organizers, especially Marine, for giving me the opportunity to speak here today and to introduce you to the new Kistler Innovation Lab in this framework of the culture cornerstones. Since the Innovation Lab is like a startup company inside the company, it is an excellent example for the cornerstone entrepreneurship. So after I took the teaser video with my captain's hat, I was thinking very hard how I can use the treasure hunting theme in my talk. And I would like to thank everybody who contributed with some very innovative ideas about that. So I like the idea to get a wooden leg, for instance, or I also like the idea to get a parrot on my shoulder, or even to rent a boat and to give my talk from the Lake of Zurich. But since I was not so sure if all of this is the right thing, I did what you usually do these days if you're looking for inspiration. I Googled for it. And now if you set Google and you look for entrepreneurship, one of the first hits, what you find is this here. So I guess you're gonna know it. It's a cartoon, it's Dilbert. So this gentleman here is Dilbert. This is his colleague Alice, and this is their boss. And the comics are usually set in a corporate context. So it starts, I want you to think like entrepreneurs. So should we take huge risks? No, the stockholders would hate that. Should we act as though we have no boss? No, that would be chaos. So will we become billionaires if we succeed? Raises are capped at 3% this year. I'm just saying you should be more creative. And then we should act? No, that's when the problems happens. So there are many reasons why we can smile about this cartoon. I guess the situation seems vaguely familiar to us, and some things seem to be sort of universal for every bigger company. It shows us mainly one thing. We have to accept a certain framework which is given to us by the way how big companies work. And many aspects which define the cliché of a startup group and of an entrepreneurial spirit just don't work inside a big company. Yet this big company supports us in other very important points. And what we want to leverage is sort of the best of both worlds in the given framework. And we can support this by the proper wording. So what we talk about here is not entrepreneurship, it's intrapreneurship. So let's go again with Google. So this time we type in intrapreneurship. And so what we get is a very interesting white paper by Deloitte Digital. And this white paper has the title, The 5 Insights into Intrapreneurship. So number one, intrapreneurship describes a people-centric bottom-up approach to developing radical innovations in-house. Sounds great, absolutely what we want. Second, intrapreneurship pays off many times in terms of company growth, culture, and talent. Amazing, exactly what we want. The third one is already quite interesting. It's not about creating intrapreneurs, it's about finding and recognizing them. And actually inside this paper of Deloitte, they claim that 20% in a company have this entrepreneurial spirit and culture. And the only thing we need to do is leverage them, find them, and empower them, which is a nice thinking, I would say. So the fourth one is a bit critical. So entrepreneurs know the rules and break them actively. And I think point 4 should really not encourage us to start a revolution, but it should rather encourage us to find ways to get things done. Just an example, it cannot be that, for instance, the lack of an SAP number is seen as an impossible obstacle to catch a spontaneous opportunity. So it's not about starting a revolution, it's about finding solutions. And number 5, entrepreneurship requires a different management approach. And this is also one point which was already stressed by Thomas Varketin in his talk on last Tuesday. And I think if we see all these 5 points, these 5 insights into entrepreneurship, as they were claimed by Deloitte, we have to give a great credit to Kistler, because people realized that this is key to mobilizing a giant potential within the company. And we are taking the necessary steps, such as kicking off the KI 1000 transformation or creating an innovation lab, or like setting some more focus on culture. And to make this clear, I will show you one slide that we all have probably seen countless times in the past year. This slide shows Kistler's very impressive talent for transformations in a quickly changing environment. So over the last 20 years, we have evolved from a component manufacturer, from a supplier of sensors, into a provider of systems, into a provider of solutions. And KI 1000 now sets the basis for a digital transformation, which will turn Kistler into an information provider. And this gives us the ability to create value through software and open new business opportunities for our customers with big data, data mining, information as a service, and so on. Software development will become even more important in the future. And to support this transition, the new Kistler Innovation Lab was created. And this is what today's talk will focus on. Before we dive deeply into the topic, I would like to introduce you to the team of digital enthusiasts and entrepreneurs. So that's myself, I'm heading the Innovation Lab. Thomas Wurmann is our project manager. Sandra Haltmeier is doing her internship and is our junior data scientist. And we also have some part-time collaborators, Patrick from Karlsruhe, Patricia from Bratislava. And this guy here actually is an interesting one. He's the only true entrepreneur in this team, because he's heading a digital startup in Berlin, and he helped us with some first projects. This is the outline of my talk. So in the first part of my talk, I will speak about the general concept of the new Innovation Lab. In the second part of my talk, I will quickly report on 3 successful proof of concept projects, which nicely show the working principle of this new instrument within Kistler. So let's start with the why. This is our vision for the Kistler Innovation Lab. We will turn data into value. We unveil the full potential of data by combining sensor technology, domain knowledge, and data science. So as a company for measurement instrumentation, Kistler can access this incredible treasure of data, or at least we can control the technologies with which we collect this data. And we're absolutely convinced that inside this data, immense amount of informations are hidden, which are just waiting to be released with the help of suitable methods. So Kistler is in an amazing position since we provide software as well as hardware, and we have the option to deliver solutions which are consistent along the entire measurement chain and also along the entire value chain. Now, Kistler's product portfolio is extremely diverse. And that means that for almost every measurement challenge, we find an expert or a sparring partner in-house. The only aspect which is still missing is a certain expertise in data science. And the Kistler Innovation Lab is exactly the vessel to lift this onto a new and future compatible level. On the next slide, I would like to explain the mission of the Kistler Innovation Lab. We are an evolution driver. So Kistler has an excellent reputation as an innovative high-tech company. We have an excellent basis on which we can build and which we can extend for sustainable success. And all this goes hand in hand with the digital transformation plans. It's absolutely clear that we cannot just build on our success if we want to grow sustainably. We have to actively take the path into this new digital age. This we want to do by being a digitization booster. So Kistler gained a size and a level of complexity which makes it difficult to start and support initiatives quickly. But it's absolutely necessary for a fast transformation to partly decouple initiatives from the corporate processes and create some vessels which allow accelerated development. So we need to leverage this transformation to fill our toolbox with some new technologies. The Innovation Lab offers exactly this framework to be the booster for digital technologies and for data science, and we will act like a startup company inside this corporation. We would like to be an opportunity explorer. So we want to be exactly this lab vessel, which allows to accelerate innovation in a technical as well as business context. And this allows us to access all levels of the Kistler technology stack, but also all levels of the company hierarchy. These new digital business models allow us to communicate on a completely different level of the hierarchy, also at our customer side. Last but not least, we want to be a co-creator. And I count this one as one of the most important points. So we will orchestrate co-creation projects with our customers and partners, and also within Kistler, to support the digital journey and to share some knowledge and data. This allows us to make one big step ahead in terms of technology and to create success stories, and we can prove the world that we're an important player in this digital game. So what exactly do we want to do with the Innovation Lab? On the next few slides, I would like to describe our offering to you. First of all, we would like to leverage this triangle of knowledge. So as I already mentioned, one special thing about Kistler is that one can find experts and sparring partners for a whole zoo of different applications. So I experienced it as a really unique thing about this company, that these three expert groups can be easily brought to collaboration. The technological knowledge, the deep knowledge about a specific domain, and a good understanding of different business models and value creation. So for every new project which is started based on measured data, a contribution of all of these players is appreciated. Only like this we guarantee an efficient value creation, technical excellence, and also a close inclusion of the customer. So the Innovation Lab will orchestrate projects and will pay attention that all of these players have a balanced contribution. In our first project, we realized already how challenging this can be. So speaking, for instance, about industrial production processes, the domain experts are often people from the shop floor. And you can easily imagine that they do not have so much in common with the data scientist, and that these people do not speak the same language. Working towards a shared strategy and goals helps. But anyway, a lot of patience, goodwill, and a common ground is absolutely important for efficient projects. So in my teaser video, I spoke about the three islands where we are gonna land. The island of co-creation, the digital technology incubation island, and the island of training. So here I would like to explain this in a bit more detail. First of all, co-creation is supposed to happen inward within our Kistler team and also outward with our customers. And co-creation by itself is a beautiful name because it means that we create something together and everybody contributes in the framework of his or her capabilities. By sharing their data, the customers can make sure that they will get a perfect solution which exactly fits their needs. And we, on the other hand, we can make sure that we are creating database services and solutions which are meaningful and which create value for our customers and us. To show what the digital technology incubator is, we use this picture of the tiny plant. So the plant needs to grow in a protected environment in order to get some strong roots. And this sets the basis for strong growth in the future. We can imagine these digital technologies at Kistler in a very similar way. So the Innovation Lab provides the protected development framework for fast success. Sometimes, unfortunately, our daily business of technology development does not offer us much space for creativity. The way we work is dominated by deadlines, by the budget, by resource allocation, and also by timescales. On the other hand, in a creative environment, like at Kistler, where we have a lot of highly educated and motivated people, we have a lot of nice ideas, which are just separated from value creation by a quick experiment. And this technology incubator should be exactly this framework for fast experiments. And a project is counted as successful if it triggers a product development, if it provides a building block for a future product, or if it sets the basis for a strategic decision. And after a proof of concept is done, we will hand over our projects to the product development. The last island or the last pillar of the Innovation Lab is the Digital Training Center. And this is a tool to upskill our team. We would like to present the digital Kistler technology stack, and we would like to present some valuable core technologies for the future. With this, we want to empower everybody to recognize digital business opportunities and also to leverage them. How? How do we want to do this? I will speak about culture and about co-creation. So this is a culture cornerstone talk, so the culture is especially important to us. Culture eats strategy for breakfast. This is a very famous quote from Peter Drucker. And with these words, he really didn't mean that strategy was not important. He rather wanted to stress the importance of an empowering culture. And therefore, we need to take the time to think what kind of spirit we want to establish and what kind of attitude we would people like to have to drive this initiatives forward. And I would say the Kistler culture is a good basis on which we can build to create this startup group. And the Innovation Lab is something like a startup company within the company. So on top of the traditional values, we want to introduce a certain dynamic and entrepreneurial or intrapreneurial spirit into the company. We want to value the existing structures and knowledge, and yet we want to make people curious for the new. We want to build bridges and we want to foster the collaboration. We want to actively take up the challenge to unite the best of two different worlds. And for this, we want to leverage these 4 C's. We want to be creative, competent, committed, and collaborative. And about the collaboration, I would like to say a few words on the next slide. So as I said, we would like to foster collaboration inward towards the Kistler team and outward towards our partners and customers. There are basically 2 different ways how a project can be submitted to the Innovation Lab. So the market-driven projects will be submitted by our customers, by our business units, and by our external partners, like for instance, universities, development partners, or the research and development departments at the customer side. They can submit their project ideas at the Innovation Lab, and they can get support in digitization topics or with some sensor-specific data science. Solutions will be developed in a co-creation approach then. Technology-driven projects, on the other hand, can be suggested by our technology department. So in a strategic context, we sometimes just need a quick test to push certain technologies into the tech roadmap or to create a decision basis for some future developments. And for some projects, it's not really possible to draw a strict line. So good examples are technology projects, which we do together with universities, or some explorative tests in our own Kistler sensor production. Later, I will show you exactly one of these projects, which was a lot of fun since the team was close and communication paths were very short. So among you guys, I hope to find a lot of people with some market access, some salespeople, some business developers, and so on. And I would like to show you, so in case you have a customer who's very interested in a co-creation project, how exactly this works. And I really hope that you will find this really inspiring. So first of all, you will get in touch with a Kistler expert. So you and your customer, you will discuss, okay, I have a certain challenge and this could be solved with data. This could be solved with data and it could trigger a database service or solution which will help myself or my employees, my team inside our processes. When you formulated this problem, you will reach out to us and we will organize a workshop. And with this workshop, with the Kistler Innovation Lab, and with the experts from the domain, and with the sales guides, and of course with the customer, we will frame the problem, we will discuss the feasibility, and we will discuss what it needs to get this done. Then we will set up a proper IT infrastructure at the customer side. For instance, for a production case with the Comuneo or with the Maximus, we might need to install a Quisio to collect data and also to later deploy the solution. And we will figure it out with the customer, find a solution, how we can do this based on their IT infrastructure. The next step is a deep dive. So the Innovation Lab will take some time, will dedicate some resources to create something like a minimum viable product, like a proof of concept, to prove what we can accomplish with the means of data science in this given environment. And later, last step is deployment. And we hope that these kinds of projects can trigger a product development and they can trigger us to deploy a proper solution at the customer side. Okay, so this is already the first part of my talk. This was about the general concept of the Kistler Innovation Lab. In the second part of my talk, I will show you 3 different projects. And the first one is about quality predictions in metal machining. So this entire project is driven by a vision. At Kistler, we have, for instance, 2 examples for extremely successful products in our portfolio, and this is the Maximus and the Comuneo. And they create a big value in their specific domain, since they help to increase the production process stability, and they allow us to make reliable statements about the quality. In other domains, such as metal machining, Kistler also has some powerful sensors and some powerful measurement solutions, but features like in the Comuneo are missing. This is mostly due to the fact that the processes are significantly more complex and significantly less systematic than, for instance, in injection molding. Our vision is that we can use data science based on the cutting force in metal machining to develop a data-based service which allows us to predict the quality and increase the process stability in a similar way as it is done with the Comuneo. So let's dive deeply into this process with a short video. What I show you here is a process inside a lathe. So a lathe is an instrument which can machine some rotational symmetric parts. Here you see 2 examples of 2 parts which are produced in our own sensor production. This is the lathe. It's a highly engineered machine which can use all kinds of different tools and move them. So for instance, you see here a collection of drills and knives which are used inside the lathe. This shows you the basic operation of the lathe, how it can machine the parts. This is now an example. What you see is how the knives and the drills cut the material from a rod-shaped piece, and they do one process step after the other. And you can see it's quite a lot of different process steps, which are done in an extremely precise way with an accuracy of microns. So after the entire process is finished, the part is parted off, and we do a manual quality inspection where a person measures the accuracy of the fabricated parts. And we record quite a lot of different data. This now in the end shows you how these parts are used in a typical Kistler sensor. Okay, now what is our challenge? So as I showed you inside this video, our challenge is that several different process steps are done before we do a manual quality inspection. So if something goes wrong inside the process, we only know at the end that something went wrong, and we have no idea which one of the processing steps caused the failure. So here you see what this looks like. So this is an example of this Kistler part for Kistler sensors. They're incredibly small. You see here as a scale bar my hand, and the precision of these parts is a few tenths of microns. So it would be immensely helpful to the people who operate the machine to identify these process steps which are fragile and these process steps which cause some bad quality. And on the other hand, the tools are really expensive. And when these tools are changed, this is actually at the moment rules of experience and best practices. So with a data-based approach, like a classical predictive maintenance case, we could probably extend the tool usage times and thus save a lot of energy and money. And I think this is also one of the nice cases where you can see the power of a Kistler parameter. Actually, the cutting force is a really great parameter. And to show you this, I would like to take you to a detour to the kitchen. So you all know the problem. You would like to cut a tomato. Now, if you have a very sharp knife, you can easily cut through the tomato, and what you get in the end is a really high quality tomato slice. So if you have a very dull knife, you need a lot of force to cut the tomato, and what you do in the end, you rather smash the tomato than cutting a beautiful piece. So your intuition also tells you that this is a really poor quality tomato slice. So after all, our intuition tells us that the cutting force is an excellent parameter to characterize the tool and the quality outcome. And this is exactly what we do with our data science approach. We use a machine learning model to detect processes which are fragile. And we do this by just assuming that this is a highly engineered machine, and the processes should be absolutely reproducible. And for every part that we machine, every step which shows something like a big deviation from a standard process is probably leading to a bad quality. And this is something that we can confirm with the data. So here I show you two examples where I always plot the cutting force as a function of time. And here you see a robust processing step. This is flat drilling. And for flat drilling, here we see something like a norm curve in red and a variation of different processing curves in blue. And you see that the variation of these curves is rather small. On the other hand, I show you a fragile process step. This is hole finishing. And you see again that the variance is in general low, but here in the end, we have a really big variance. And now we train a machine learning model. This is an XGBoost model, and this model will detect strong deviations from this norm pattern. And what we do now is we define an error score, and we plot here on the x-axis all the different processing steps as a function of this error score. And now, whenever we have a bright color, that means that we have a process with a high error score. That means that this is a process where something usually went wrong. And now this information is extremely valuable to the machine operators because they know exactly where they have to work on, which part of the process they have to improve in order to improve the quality outcome. Okay, so I think this is quite a nice result on our way to improve quality and increase process stability. So what can we do next? So first of all, of course, we have to use these results in our own production. We have to develop this model so that it's a real product, that it's robust, and that we can sell it to a customer. But at the same time, we could also offer some consulting services. If a customer actually measures this data, measures the cutting force, we could do the same kind of analysis for them and offer this knowledge about the perfect processing steps to them as a consulting service. Just as an idea for some new business models. Okay, then I would already like to go to our second project. And our second project is based on Wayne motion. So Wayne motion is a very famous technique at Kistler. It's one of our core technologies. And I like this also quite a lot because it's very intuitive. Because every one of us spends some time on the road to get from A to B. And every one of us has a certain intuition about traffic flow and what is to blame on the trucks. So we probably all have a certain intuition on how trucks cause some traffic jams and whatever they are the cause for. And so if you take a look at a typical Wayne motion site, of course we have here in the road the linear sensor, which can give us some information about the vehicle weight, about classifications, about tire anomalies, and so on. But in this site, we have so much more information, which is just a fantastic playground for every data scientist. So we are also measuring the speed, identifying vehicle dimensions, and so on. So it's fantastic data sets, which can provide a lot of additional information. But until now, not so much of this information is actually used. So these are the typical applications of the Wayne motion systems. So we do traffic data collection, weight enforcement, weight-based tolling, industrial weighing, bridge protection, and I think the fun starts where we can do data science and some new business models. So we analyzed some data which was given to us from the US in the year of 2019. And we found an interesting fact inside this data. We saw that roughly 30% of all trucks drive empty. Just imagine this, 30% of all trucks drive empty. Greta Thunberg would be shocked. An empty truck doesn't create any value. It just goes from A to B empty. It just blows CO2 in our atmosphere. And we really think that this information is super valuable because it's something that can only be accessed by Wim. So Google does not have this information. Google doesn't know if something moves, they don't know if it's full or empty. It's a very special information which we can only access by Wayne motion. On the other hand, we see that this truck flow is extremely systematic. So here we plot the number of full trucks as a function of time in the year 2019. And you see that this pattern is extremely periodic and that it's extremely systematic. And whenever you have something which is systematic, and where you can see a systematic behavior just by the bare eye, you can also train a machine learning model in order to predict this or to recognize these systematics. And we really wondered, what is the impact of this? The impact should be huge. It should have an impact on the CO2 emission, on the transport efficiency, on the road usage. What would just happen if we could use this as a new business model in order to really use this unused transport capacities? So as a proof of concept, we trained a model. So the working principle of this is we use the data from January to November to train our model, and we try to predict the behavior in December. What we used here is the so-called profit model. It's a model which was developed by the Facebook Research Lab. And here I show you our results. So again, on the x-axis, we plot the time, and on the y-axis, we plot the number of full of empty trucks as a function of time. And so these zigzag lines are always our actual measurements, our measurements of full and empty trucks. And our predictions are shown as the straight line and also as the shaded area for the error bar. And now you can see that these results are really good. So we can predict the traffic flow with a really high accuracy of less than 10 trucks. And now you can think about some next steps. What is this? What are the implications for this? We could also use other parameters. We could abstract this model to other parameters and connect it with other data sources. What does it have to do, for instance, with the weather? What does it have to do with traffic jams? Are there any correlations about this? Do we have any chance to predict this? And to whom would this information be valuable? It could work. We could work on entire new business cases and new business models, which might create a lot of customer value in different areas. Okay, towards the end, the last case I would like to show you is again a completely different one. And is again taking us back to a production contest. And this is a beautiful project because it's our first customer co-creation project. This was done together with a customer. And it's about process optimization and injection molding. So I tell you our challenge and our setting, the problem that we were trying to solve. So we had our customer, and they have an injection molding machine. On the injection molding machine, of course, they have a Comuneo, which is, of course, a very good choice. And the Comuneo sorts the parts according to the mold pressure curve into good and bad parts. And actually, the sorting accuracy of the Comuneo is excellent. So usually, this is really good enough to have a good quality outcome and a really great process stability. Now comes our customer. Our customer is Gerresheimer, and Gerresheimer produces products for medical equipment. And quality requirements are really high, so bad quality is absolutely dramatic, and one would rather trash many good parts than tolerating just one bad part inside the green bucket. And what they said is, okay, sometimes these cases are really rare, but sometimes they still have some bad parts inside the green bucket. And these parts look, for instance, like this. They have little burns, or they have these extensions here. And they would really ask us, okay, do you have any idea, any data-based approach which can tell us why this happens sometimes, that we have part like this? Or can this data-based approach tell us what we can improve in order to avoid these kinds of quality outcomes? Okay, so we did the entire process as I showed it to you. We had a workshop, we discussed this, and we provided the innovation lab approach. And this is an approach which is meant to unveil the full potential of the data with machine learning. So we do 4 steps. First, we do data exploration, then we do feature engineering, then we calculate a model, and then we validate a model. And in the following few slides, I will walk you through the entire process of what we did for our customer Gerresheimer and what the outcome was. And we realized that really one key to success, or 2 keys of success, are collaboration and detective work. We realized, especially in this project, how absolutely important it is to get all the domain knowledge from the people from our plastics department. And I will show you how. Okay, so we start with data exploration. So we took a good look at the pressure curve in injection molding. And now I'm a physicist by training. Before, I didn't have so many touch points with the injection molding process. And so maybe I can start a bit naive and I can tell you one thing. Ladies and gentlemen, this is an elephant. So, and if you take a look at these pressure curves, it is always an elephant. So this is a different kind of elephant. You see that the elephant here has a bit of a different kink inside his trunk. The ear is a bit higher and also the butt is higher. But after all, the general shape of this curve is still an elephant. This is a different kind of elephant. So here the trunk has the kink at a different point and the butt is a little bit smaller. And this is a very strange elephant. But anyway, my point is the pressure curve is always an elephant. Okay, so you have this very characteristic shape. It is always an elephant. And now describing the trunk, the ears, the butt, the tail with mathematics. This description of all these features with mathematics. This is this process which we call feature engineering. So what we did now was to extract all these features here, which are actually meaningful also according to the domain. So we had a lot of meetings with this group. They told us the meaning of the start point where the plastics enters the mold, the switchover point where the mold is sort of full and you just push some more plastics in order to compensate for the reduction in volume. This maximum point where the mold is full and the material starts to decrease again, and so on and so forth. So all of this can be nicely described with mathematics. And now we take this mathematics, we take these features and we feed them into a machine learning model. And the model that we chose is a so-called isolation forest model. It's an unsupervised learning model and it detects anomalies. And all in all, what it does is it uses this machine learning approach. It confirms the Comoneo labels for the quality, and it suggests at the same time that there might be some additional information which can be extracted further from the measured data. And with this, we would like to avoid this false positives. And false positives, this is what we call the bad parts which end up in the green bucket. And to plot this or to show this, we use a graph like this. So these are the Comoneo labels which are assigned as good. They are recognized like the same with our model. These are the Comoneo labels which are bad, and they are recognized the same with our model. And our model finds additional 122 parts where they say, okay, these parts are abnormal. And so we would say, this is probably where we can make a connection to these sources of error, which lead to the bad parts, which end up in the green bucket. And what is even better about the model is, so the model gives us a rating of our features. And this is what I show you here. And so this model tells us that for this certain anomaly, the maximum pressure was the most important feature. And now we can again take the domain knowledge. So we can use the team of around Robert Batzelik and Jonathan Kegi and Matthias Schirmer, and we can ask them, okay, what does it mean to you? And with this knowledge, we can finalize a cause of failure qualifier. So depending on which feature is rated the highest, we can say, okay, this is probably the cause of this anomaly. And we can also suggest what you can do to avoid it. So our next steps is to finalize this, to deploy it in a productive environment, and also to use these machine learning models to significantly improve the ease of use. So you could even ask, okay, if this model is doing such a great job, do you still have to set some evaluation objects, or can you let the model do it? And I think all of this still needs to be proven, but there are some very good indications that this might be a valuable way to go. And you could also think about, okay, this works quite fine, this anomaly detection models. Could we use this also for other applications? Like for instance, the Maximus is a very similar application compared to the Comoneo. Could we also use it there? Or could we deploy it on JBeam? Or any other idea which you might want to provide? And I really hope that this was some inspiration for you guys. Maybe you come up with a great idea and you would like to submit it for the Innovation Lab. So I showed you some projects, and I hope you found this inspiring, and I hope that they showed you very well how the Innovation Lab works. I would like to come to a call for action now. And my call for action is to walk the talk. So now what are we going to do? I'm absolutely convinced that this Kistler Innovation Lab is a really powerful tool to drive Kistler, our partners, and also our customers one really big step ahead. And I would like to invite all of you to join us on this journey and fill this concept with life. So one of our most important offerings is that we orchestrate projects which help us to drive the digital transformation of our customers and also ourselves forward. So we will prove our capabilities in data science, and we will try to trigger great developments of digital products and database services and solutions. So please join us for these great projects. We would like to work in a co-creation mode. And for this, we need collaborative clients and also strong partners. So this goes out to all you guys with the market access. We invite you to leverage our network and to strengthen our partnership with a perspective towards database services and solutions. So we want to deliver important contributions to the technical as well as business model innovation, because we're absolutely convinced that the best ideas come up where these two meet. And we invite you for many valuable discussions about this database value creation. And last but not least, as a company, we have to act as a role model for digitization topics if we want to create value with our customers. So let's discuss how we can leverage these new opportunities in our own labs and in our own processes and in our own production lines. So ladies and gentlemen, I really hope that my talk could convey the groove of an entrepreneurial or intrapreneurial spirit. And I hope that I convinced you about the power of the Innovation Lab in the first part of my talk, and about the power of data science and database services based on Kistler sensor data in the second part of my talk. Now, if you want to reach out, you can check out our wiki. It's completely open, everybody can access it. If you have any product ideas or if you want to discuss something, you can invite Thomas or me for a beer or coffee. Our website is coming soon, and you could also see us at the IEEE conference on data science here in Switzerland on the 9th of June in Lucerne or online. And with this, I would like to say thank you. I would like to say thank you, first of all, to our core team and to our part-time collaborators. I would like to say thank you to our collaborators inside and outside Kistler, especially to the experts in the business units who drive this innovation project with a lot of enthusiasm. I would like to say thank you to our supporters, especially also in the executive committee, especially to Mark Schad, who is always one of the best examples to find solutions in the framework which is given in the company. I would like to thank Marine for giving me the opportunity to introduce you all to the Innovation Lab. And of course, I would like to thank you for listening. Still have some time for question?
And we thank you for a great presentation.
Thank you.
Thank you very much.
So we still have some time for questions. If this is not the case, then again, an invitation to reach out to me in case you want to discuss something or in case you have some very innovative ideas. And then I still wish you a wonderful day. Bye.
Bye. Thanks.
Thank you. Bye.
Thank you. Bye-bye.
Thank you. Bye.
Very informative.